Graphing an exponential function and its asymptote, f of x equals b to the x power. To understand the graph of an exponential, let's take a look at a specific case first and then try to generalize it. The easiest exponential graph to understand is y equals 2 raised to the x power. In the graph of y equals 2 raised to the x, we can use some properties of exponents to get some understanding of what's going to happen. Well, anything to the 0 power is always 1, and anything to the first power is always that thing. So we can quickly surmise that 0, 1 and 1, 2 are going to be 2 points on the graph. The other thing I want to pay attention to is the idea that there's not going to be an x-intercept to this function. Because if we try to plug in negative values for x, two raised to any power, whether that power be positive or negative, is always going to give us a positive result. Just throwing a couple of numbers in. If we take 2 raised to the negative 1 power, we get 1/2, 0.5. If we take 2 raised to the negative 10 power, we get 1 over 1,024, which is 0.0009. If we tried the negative 100 power, we get an exceedingly tiny number. Something in the ballpark of 10 to the negative 31. So as you try smaller and smaller or more and more negative values of x, this thing is going to get small. But we know that a positive number raised to a power is always bigger than 0. So we know that y is greater than 0. But always getting smaller for more negative values of x. Visually, we call that a horizontal asymptote. You've worked with vertical asymptotes in the past, and horizontal asymptotes are much the same idea. We said we were going to go through the points 0, 1, and 1, 2. I'll also mark in here we had negative 1, 1/2. That one's reasonable to plot. And just like with vertical asymptotes, where you get closer and closer to a vertical line without touching it, in a horizontal asymptote, you get closer and closer to a horizontal line without touching it. So here's the picture of y equals 2 to the x. And we'll have a horizontal asymptote at y equals 0. This will always work out So in general, when you have a function f of x equals b to the x, you're always going to go through the points 0, 1, 1b, and negative 1, 1 over b. And you are always going to have a horizontal asymptote at y equals 0. Generally, this negative 1, 1 over b is not really that useful to us, except when b is a fraction, in which case things kind of flip their picture a little bit. So let's take a look at one more example. This time b is 1/2, and we're looking at f of x equals 1/2 raised to the x power. And again, I'll sketch out some coordinate axes. Right, the horizontal asymptote y equals 0 is the x-axis. We don't have to draw anything else. When we start playing around with positioning on exponential functions, when we start making these things a little bit more complicated, the horizontal asymptote can and will move, but for right now it's always the x-axis, which is really convenient. And again, once things start moving around, this will change, but for right now, for the simplest form, we know we're going to go through the point 0, 1. We know we're going to go through the point 1b, which in this case is 1/2. And we know we're going to go through the point negative 1, 1 over b, which in this case is negative 1, 2. So that's where the negative 1 comes in. It's a lot easier to find the point negative 1, 2 than it is to find the point 1, 1/2. Either way, you're going to draw a curve that's going to become shallower and shallower so it can get through all three of those points, and then it's going to taper off so that it comes as close to possible to the x-axis without crossing it. So here's your graph of y equals 1/2 to the x, or y equals f of x for f of x equals 1/2 to the x.